Recent discoveries from the James Webb Space Telescope challenge everything we believed about the universe's origins. These findings raise the possibility that our comprehension of the oldest galaxies and the Big Bang itself may require a substantial re-evaluation. Welcome to Spaceverse, the ultimate destination for cosmic enthusiasts and stargazers alike. Join us on a thrilling journey through the mysteries of the universe, from distant galaxies to groundbreaking space discoveries. Subscribe now and become a part of our cosmic community as we explore the wonders of the Spaceverse together. In 2022, an image captured by the telescope stunned the scientific community. It revealed distant galaxies and reddish specks of light that don't align with our prior understanding of the early universe. These enigmatic galaxies, numbering in the hundreds, are revolutionizing our perception of what we refer to as the Dark Ages. This prompts the question: are we standing on the cusp of a scientific revolution? The Maisie's Galaxy. Among these newly discovered galaxies, there is Maisie's Galaxy, which was found by the astronomer Stephen Finkelstein from Austin, Texas. He named it Maisie's Galaxy in honor of his daughter Maisie as he made this momentous discovery on her birthday. Initially, the scientific team believed this galaxy had formed shortly after the Big Bang. Initial distance measurements indicated an astonishing age of over 13.5 million years, suggesting that it existed just 190 million years after the Big Bang. However, a more meticulous analysis with advanced equipment revealed that it was another 100 million years older than initially estimated. While Maisie's Galaxy held the title of the oldest observed galaxy for a brief period, it was soon surpassed. Currently, Sears's team is assessing around 10 other galaxies that may be even older than Maisie's Galaxy. If their findings confirm the existence of galaxies even closer to the Big Bang, it could have profound implications. With each new discovery made by the James Webb Space Telescope, the gap between the Big Bang and the formation of stars and star systems continues to shrink. But the telescope's contributions go beyond this, as it has recently uncovered a type of star that was previously only a suspicion. James Webb, often humorously referred to as the mighty eye of NASA, is poised to permanently alter our understanding of the cosmos. The James Webb Space Telescope, or jwst, has uncovered 3 potential dark stars, which were previously purely theoretical. Dark stars derive their energy from dark matter, and though it may sound paradoxical, these stars have the capacity to shine more brilliantly than any other stars over an extended period. Dark matter, which is believed to constitute the majority of the material in the universe, remains invisible to conventional telescopes. Detecting its presence is achievable solely through gravitational effects, or in simpler terms, the gravitational force that warps space-time due to its substantial mass. Dark matter typically does not emit light, yet it possesses an unusually significant mass. This mass generates intricate interactions within space. In the context of dark stars, the weight of this imperceptible matter can initiate processes leading to the production of light. This is akin to how a rapidly spinning dust disk compressed by its own gravitational force eventually triggers nuclear fusion. In contrast, regular stars like our Sun are fueled by ordinary matter, with dust and gases colliding, swirling and accelerating, becoming progressively denser and heavier. Dark stars, on the other hand, draw their energy from dark matter particles. This development is highly captivating and may open doors to long-sought answers. If dark stars indeed exist, they might hold the key to comprehending the processes responsible for generating light in the early universe. For approximately 15 years, scientists have entertained the notion that dark stars might have been among the universe's first stars. Previous scientific estimates place the emergence of the initial stellar evolution at around 700 million years after the Big Bang. However, the discovery of entire galaxies that existed a mere 300 million years after the Big Bang challenges these prior assumptions. The enigma of dark stars. If the existence of dark stars were to be confirmed, it might shed light on how galaxies could have formed at such an early stage in the cosmos. In the context of dark stars, the observations made by Webb indicate that 3 remote objects possess all the crucial characteristics of dark stars. They emit light but are too cool for fusion processes. These 3 potential dark stars, namely Jade, GSC13-0, C12-0, and Z11-0, would in essence not be galaxies, but rather enigmatic celestial bodies with properties akin to dark stars. To address the previously unexplained aspects related to dark stars, Scientists are scrutinizing fluctuations in light intensity, seeking patterns in light frequencies that are typical of such stars. Nevertheless, it's important to acknowledge that this measurement technique is fraught with uncertainty given the vast distances involved. Despite the strides made in modern technology, making definitive assertions about objects so remote remains a formidable challenge. The quest for answers regarding phenomena at the edges of the temporal cosmos resembles a puzzle played out in the obscurity of time. Scientists can only rely on established values and principles of physics. However, it is crucial to acknowledge that there may exist additional variables, forces, and unknown factors beyond our current understanding. It is in this context that the jwst introduces a fresh challenge to scientists. The prevalence of galaxies in the early universe exceeding expectations in terms of number, mass, and luminosity, in comparison to conventional models of cosmic history, raises significant questions. These discoveries could potentially unveil the actual age of our universe and clarify that certain cherished scientific theories may require reevaluation. Professor Gupta's groundbreaking theory on the actual age of the universe has garnered significant attention. Rajendra Gupta, a distinguished physicist at the University of Ottawa, stands on the precipice of worldwide recognition if his pioneering theory gains acceptance. Gupta is among the first to propose innovative scientific approaches capable of elucidating the enigmatic findings of the James Webb Space Telescope. His theory offers a solution to the perplexing enigma of early galaxies that seemed implausible until now. Notably, Gupta's theory doesn't merely involve adjusting the timing of the Big Bang to accommodate these new galaxies. It is underpinned by substantial merit and relies on two key alterations to established fundamental assumptions. Traditionally, scientists have gauged the universe's age by measuring the time elapsed since the occurrence of the Big Bang. The second dimension pertained to studies of the properties and physical behavior of the cosmos' most ancient entities. Until the advent of the APO of Hubble, these parameters seemed reasonably accurate. Despite lingering unanswered questions, no paradigm-shattering phenomena such as the existence of impossible galaxies or perplexing celestial bodies had materialized. The estimation of the universe's age depended on the phenomenon of redshift. As light traverses the expanses of space, it undergoes a lengthening process, resulting in a shift towards the red end of the spectrum. The greater the distance to an object, the older it is presumed to be, marked by an escalation in redshift patterns. The prevailing consensus was that our universe should be approximately 13.79 billion years old based on these redshift observations and other pertinent criteria. This view represented the conventional model of cosmic evolution at that juncture. However, the arrival of the Webb telescope brought with it a series of discoveries that challenged these established paradigms. An inaccuracy in the redshift phenomenon occurred. Professor Gupta's research drew inspiration from a significant revelation dating back to the 1920s, which is credited to an obscure astrophysicist named Fritz Zwicky. Zwicky's tired light theory challenges the prevailing belief that the redshift we observe is solely a result of galaxies moving away from us. Instead, this theory proposes that redshift values may also stem from the gradual loss of energy as light traverses the universe. In essence, this theory undermines the assumption of an expanding universe, as accepting it would lead to the generation of inaccurate measurements. Furthermore, another physicist from the previous century, Paul Dirac, introduced a noteworthy yet relatively overlooked hypothesis. Dirac's work revolved around coupling constants, which describe fundamental principles governing the motion and interactions of particles. According to Dirac, these constants might have undergone changes over time, implying that particles behaved differently in the early cosmos compared to their behavior today. This notion could potentially account for why the galaxies unveiled by Webb appear to be so advanced in their development, and why other existing assumptions about the cosmos and its fluctuations have thus far failed to yield conclusive explanations. Are we persisting in obscurity, or is illumination on the horizon? The prevailing question at present revolves around whether scientists can formulate fresh, universally applicable models and theories founded on current observations. We might find ourselves at a juncture where the scientific community undergoes a schism until irrefutable evidence emerges. Such evidence may potentially manifest in the form of sightings of galaxies that predate those in James Webb's inaugural Deep Field image. Scientists have projected the telescope's range to span 13.5 billion years. Yet over its operational lifetime, the most advanced human-built telescope could potentially offer a glimpse even further into the universe's youthful epochs. It may necessitate the advent of an entirely new telescope or the revelation of novel insights concealed within the spectrum of light to unearth answers to these questions. This situation should be recognized as a significant challenge. Scientists must refrain from anchoring themselves to antiquated theories and asserting their infallibility when the cosmos presents evidence to the contrary. Lastly, some of the universe's most profound inquiries remain unanswered. Questions persist about the true nature of dark matter and dark energy, the trajectory of our cosmos, and whether it possesses an ultimate terminus. Moreover, the very concept of a cosmic origin remains an enigma. We must remain open to the prospect that we inhabit an infinite universe bereft of a discernible commencement or conclusion. Although the conventional model of cosmology and the notion of the Big Bang have long appeared harmonious, unresolved questions, such as the events occurring in the initial fractions of a second following the Big Bang or the genesis of elementary particles and atoms, continue to elude resolution. And that's it. Don't forget to like, share, and hit that subscribe button to stay updated on the latest cosmic revelations. Your support fuels our mission to bring the wonders of the universe to your screen. Until next time, keep looking up.